Have you ever had an idea that sounds brilliant at first, but the more you think about it, the worse it gets? One of those ideas is this: why don't we just launch nuclear waste into space? It sounds like a clever, futuristic solution to one of the most persistent problems of nuclear energy. Shoot the waste out of Earth's atmosphere, maybe into the sun or into deep space, and never worry about it again. But the deeper you look, the more this idea collapses under its own weight. It's not just impractical, it's reckless, absurdly expensive, and wildly dangerous. To understand why, we need to begin with a simple question. What exactly is nuclear waste? The term nuclear waste includes a wide range of radioactive materials left over after energy production or nuclear activities. Different countries classify waste in different ways, but generally it's split into three categories: low-level, intermediate-level, and high-level waste. Over 90% of nuclear waste is low-level. Things like protective gloves, contaminated tools, and clothing exposed during routine operations. This kind of waste isn't especially hazardous and is relatively easy to manage through containment and disposal. About 7% is intermediate-level waste, including reactor parts, filters, and chemical sludges that have been exposed to more radiation. These materials require stricter handling and are often sealed in cement or glass and stored underground for safety. Then there's the remaining 3%, the most dangerous kind: high-level nuclear waste. High-level waste is mostly spent nuclear fuel, the radioactive core of the reactor after it's been used to generate power. These fuel rods are incredibly dangerous, remain hot for decades, and radioactive for thousands of years. And it's precisely this kind of waste that people imagine sending into space. At present, there are around 440 active nuclear reactors around the world, and they generate about 11,000 tons of high-level waste each year. Since the commercial use of nuclear energy began in the 1950s, over 400,000 tons of high-level radioactive waste have accumulated globally. Many governments treat the problem like a hot potato, building temporary storage sites and avoiding long-term solutions. The result is a growing mountain of toxic material, waiting for someone to figure out what to do with it. And that's when someone says, "Why don't we just send it all into space?" Space is vast, empty, and uninhabited. On paper, it seems like the perfect dumping ground. But the first major obstacle is cost. Sending anything into space is extremely expensive, even with modern rocket innovations. Even with SpaceX lowering prices, the cost of launching payloads into orbit is still thousands of dollars per kilogram. Currently, it costs about $4,000 to launch just 1 kilogram into low Earth orbit. Now imagine nuclear waste. It requires heavy shielding, robust containment, and top-tier safety protocols, adding a lot of weight. If 1 ton of nuclear waste costs $4 million to launch, then 11,000 tons per year would cost $44 billion just for this year's waste. That figure doesn't even include packaging, safety systems, logistics, or launch site infrastructure. And we're not even addressing the legacy waste, the 400,000 tons already stored across the planet. Sending that stockpile into space would cost more than $1.6 trillion. Let's say somehow we had that kind of money. We'd still hit a massive logistical problem: launch capacity. In 2021, the global space industry achieved a record 135 launches, more than ever before. Even if every single rocket carried nothing but nuclear waste, we'd only be able to remove about 800 tons per year. That's not even 10% of the yearly waste production from nuclear reactors. To actually keep pace, we'd need hundreds or thousands of dedicated launches annually, just for garbage. And that's assuming we only want to reach low Earth orbit. But there's a serious problem with that plan. Objects in low Earth orbit eventually fall back to Earth because of atmospheric drag. Which means barrels of radioactive waste could re-enter the atmosphere and crash back to Earth in the coming decades or centuries. So maybe we send it farther, say to the moon. Let's do the math. A Saturn V rocket could carry about 43 tons of cargo to the moon. To manage a single year of waste, we'd need over 250 launches. Each of those launches would cost more than $1.5 billion. That's an unimaginable scale of effort and money for a trash problem. What about shooting it into deep space, where it'll never come back? Unfortunately, deep space isn't just an empty void. Everything in space follows orbital mechanics. Some trajectories could loop back toward Earth or pass close enough to be pulled by Earth's gravity over time. Can you imagine barrels of radioactive waste falling from the sky centuries from now? And then there's the popular fantasy, throwing the waste into the sun. The sun seems like the ultimate incinerator, but ironically, it's incredibly hard to hit. To reach the sun, a spacecraft must cancel out Earth's orbital velocity, a massive energy challenge. It actually takes more fuel to reach the sun than it does to escape the entire solar system. That means we'd need rockets more powerful than anything ever built, just to throw away our trash. And that's still not the most terrifying part. The scariest risk is what happens if something goes wrong during launch. Rocket failures still happen regularly. In 2021, 11 out of 146 launches failed, about an 8% failure rate. Now imagine a rocket carrying several tons of nuclear waste exploding mid-air. That explosion would scatter radioactive particles across the sky, poisoning the air, water, and ground for miles. Each launch could become a potential mini Chernobyl if anything went wrong. So no, launching nuclear waste into space isn't a visionary idea. It's a disaster waiting to happen. That doesn't mean we're doomed. There are serious science-based solutions being developed right here on Earth. Some countries are building deep geological repositories, massive underground facilities carved into stable rock layers. Finland's Onkalo project is the world's first permanent geological repository, buried in bedrock that's been stable for over 1 billion years. This type of storage isolates the waste from the environment for thousands of years with minimal risk of human interference. Meanwhile, some nations are also working on nuclear reprocessing, recycling waste to extract usable fuel. France has been doing this since the 1980s, turning plutonium and uranium from spent fuel into new reactor fuel. New types of reactors can even consume some of the most hazardous isotopes, shortening the danger period from millennia to just decades. And here's something shocking. Coal plants actually release more radioactive material into the environment than nuclear plants do. Each year, coal-fired power plants release about 36,000 tons of radioactive material through their ash. That's more than 3 times the total global output of high-level nuclear waste from all reactors. Coal contains natural radioactive elements like uranium and thorium, which become concentrated in ash after combustion. Unlike nuclear waste, this radioactive ash is loosely contained and often dumped in ponds, rivers, or landfills. Some of it ends up in concrete, building materials, or even in the air around coal facilities. Communities near coal ash dumps have been shown to face cancer risks thousands of times above safe limits. So while we panic about nuclear waste, and rightly so, the coal industry is quietly spreading far more radiation every single year. Nuclear power isn't perfect, and its waste is a real challenge. But the solution isn't to load it onto rockets and cross our fingers. The path forward lies in science, responsibility, and long-term commitment. We need to develop advanced repositories that safely isolate waste for millennia. We need to invest in technologies that recycle and reduce the danger of existing waste. We need to build new reactors that can use today's waste as tomorrow's fuel. But above all, we need to stop searching for magical solutions to complex problems. Managing nuclear waste won't be solved by dramatic stunts or science fiction shortcuts. It requires the steady, focused work of scientists, engineers, and governments over generations. The challenge is enormous, but not impossible. We've conquered difficult problems before. We can manage this one too, if we choose responsibility over fantasy. If you found this exploration fascinating, make sure to like this video and subscribe to our channel. Your support helps us bring these vital issues to more people. Thanks for watching.